Okay, I'm just going to go ahead and let people join, but get started. Thank you so much. Welcome to everyone to our webinar on the opt-in energy code and new construction in Wellesley. My name is Mary Beth Martello, and I'm Wellesley's Sustainability Director. Next slide. This webinar is sponsored by the Select Board and Wellesley's Climate Action Committee. And the reason for us being here is really the existence of an article going before town meeting this spring to see if town meeting will adopt the municipal opt-in specialized energy code, what we're calling tonight the opt-in code, to make it effective January 1st, 2024. And what you see on this slide is the language of that article and the motion. Next slide. And the agenda for tonight is to start off with a little housekeeping on meeting protocol, then talk about Wellesley's climate goals and an intro to the opt-in code, take a deeper dive into the code provisions, talk about passive house and multifamily projects, and end with some high performance building information before segueing into questions and answers. So next slide. The meeting is being recorded, and we will distribute that recording along with slides later this week. You are welcome to enter your questions in the chat, and we will try to get to as many questions as possible during the live Q&A segment. Any outstanding chat questions we will follow up on after the meeting, and we ask that we minimize dialogue in the chat during the meeting because that can be distracting. During Q&A, if you would like to ask a question, please use the Zoom raise your hand function or type a question into the chat. And please make sure that you're muted unless you're asking a question. So if everyone could just check their mute buttons right now and make yourself muted as we go forward, because there's sometimes feedback on the line. And next slide, please. And I want to thank our guest panelists. We are very fortunate tonight to have an illustrious set of speakers, and they are Tom Catalano, a principal at Catalano Architects, Mark Doty, a principal at Thought Forms. We have Ian Finlayson, sorry. He is Director of Energy Efficiency Division at the Massachusetts Department of Energy Resources. And Ian was instrumental in leading development of the opt-in code and all of the code updates that we're talking about tonight. So very fortunate to have Ian here. Hank Keating, President of Passive House Massachusetts, and Laura Fatt, who is Senior Associate Architect and Sustainability Strategist at Feingold Alexander Architects. Next slide. And the webinar that we're doing tonight is really part of a series of outreach initiatives that we've engaged in since October. So we've been speaking to boards and committees across town. We've developed a website with resources for the public to learn more. We've been having one-on-one conversations with building professionals. We have a webinar again this Wednesday for the general public, and we'll continue our outreach after our webinars leading up to town meeting on March 27th. Next slide. So Wellesley's greenhouse gas emissions goals. We've had town-wide greenhouse gas emissions reduction goals since 2009. The most recent iteration of those goals was adopted by town meeting in 2021. And our new goals are to reduce town-wide emissions by 50% below a 2007 baseline by 2030, a 75% reduction by 2040, and to net zero emissions by 2050. Next slide. And this is a snapshot of our carbon footprint townwide in 2021. And you can see that buildings contribute about 60% of emissions. And if you look inside that contribution from buildings, you can see that the residential sector is contributing about 37% of that. It's 37% of that 61. And then we have about even emissions contributing from the colleges and commercial sector and about 2% from the municipal buildings. The next slide. This slide shows metric tons of carbon dioxide equivalent according to Energy Source. And you can see that in our buildings, which are represented by the 3 bars on the left of the graph, natural gas is the biggest driver of emissions, followed by fuel oil and electricity. We need to get all of these bars to zero or to net zero. And electricity is moving in that direction already because we are increasingly bringing on renewable sources like solar, hydro, and wind to power the grid. Natural gas and fuel oil, however, will only reduce as we use less of them. Next slide. So steps to net zero buildings by 2050 involve minimizing our energy use, maximizing energy efficiency, electrifying our mechanical systems and our appliances, and then powering with renewables. These steps underlie Wellesley's Climate Action Plan section on buildings. They underlie our state plans for buildings, and they are inherent, as you will see, in the opt-in code. Next slide. So now moving to some details about the energy code. I'm going to start with a history. Next slide, please. Of the stretch code. It was developed in 2009 and designed to be about 20 to 35% more efficient than the base code. Wellesley adopted the stretch code in 2011, and the Climate Act in 2021 moved the authority for the stretch code from the Board of Building Regulations and Standards to the Department of Energy Resources. In 2022, the Department of Energy Resources, or the DOER, provided, I think, 2 straw proposals and allowed comments on those. Wellesley commented, I think, in both rounds, and then DOER issued the update, the energy code update language in September, and that is when Wellesley's Climate Action Committee and Select Board came together in the fall to decide to co-sponsor that opt-in code. Next slide. This is a map that shows the codes that are in place in different towns and cities across Massachusetts. The light areas represent where the base code is in effect. The light blue areas, which is about 300 towns and cities, reflects where the stretch code is in place. And the darker blue areas that are in the inset, so Somerville, Watertown, Cambridge, and Brookline, represent communities that have already adopted the opt-in code that we're talking about tonight. Next slide. So these, as I said, these starred communities have adopted the opt-in, and we know that the other towns listed have sort of opt-in plans in place, and I think that towns, many more towns than are pictured here, are moving toward the opt-in code as well. Next slide. So this slide shows sort of the nested nature of the different levels of code. As I mentioned, in September, DOER issued an updated stretch code and then the opt-in code. And they are based on the International Energy Conservation Code with Massachusetts amendments and appendices. Next slide. Because Wellesley is already a stretch code community as of 2011, the updated stretch code is automatic for Wellesley. Next slide. The opt-in code, however, requires a vote from town meeting. Next slide. And there's another level that DOER has offered to communities. They've developed a 10 community demonstration pilot that communities can volunteer for. And this pilot involves prohibiting fossil fuel in new construction projects. Next slide. And these are communities that have expressed an interest in the pilot. You can even see that there's a wait list to be part of this pilot. It's very popular, and it reveals that Wellesley is not even at the cutting edge of energy code work, given that the pilot is even more stringent than the opt-in code. Next slide. So now to talk a little bit about the details of the opt-in code, I'm going to give a bird's eye view of the code, and then Ian is going to delve in more detail into the provisions. So the opt-in code applies only to new construction, not to renovations or additions. It's consistent with emissions reduction goals for the state and the town. And some of the key requirements in the opt-in have to do with electric pre-wiring, solar, passive house, and an earlier start date for the HERS Energy Efficiency 42 requirement. Next slide. These are slides that Janet Mosley prepared, and she's the sustainability analyst in town. And this slide shows residential low-rise buildings. And it's comparing from stretch and opt-in code for minimum energy efficiency, for electrification, and for renewable generation. So if you look along the left-hand column, you see that there's two types of dwelling units addressed in this chart. One, dwelling units less than 4,000 square feet, and dwelling units greater than 4,000 square feet. The white rows reflect all electric buildings, and the light blue rows reflect mixed fuel buildings. Mixed fuel buildings are those that include some form of combustion. And you can see that the stretch and the opt-in code are the same for the all-electric scenarios. The green writing in the light blue rows reflects where the opt-in code differs from the stretch code. So let's look at dwellings up to 4,000 square feet in size. If there is a form of combustion in the building, let's say there's a gas dryer, the house would have to include electrical service sufficient to power an electric dryer in the future. And it would also have to include a plug in the location of the gas dryer to accommodate an electric dryer in the future. There's also solar requirements that Ian's going to talk about in more depth. Now let's look at the dwelling units that are greater than 4,000 square feet. And these are low rise, of course, in the light blue row. For mixed fuel buildings of this size, they have to conform to HERS 0 or Passive House 0. So they're essentially zero energy buildings. That means that the renewable energy on site has to be sufficient to power the building on an annual basis. These buildings also require that pre-wiring that I just described. Next slide. This slide presents commercial buildings and as well as large multifamily. And you can see that for offices, for small commercial buildings, and for high ventilation buildings like hospitals and labs, if there is all electric in the building, the stretch code and the opt-in are the same. If there's mixed fuel, pre-wiring and solar are required. There are some exemptions for solar, and Ian will go into that. I want to call your attention to multifamily dwellings on this page. So these are multifamilies greater than 12,000 square feet. It's important to note that for both all electric and mixed fuel multifamilies of large size, they must either be passive house or conform to HERS 0. And that, again, that's whether they're electric or mixed fuel. And we're going to hear about passive house from Henk Keating later tonight. And if it's an all-electric building, of course, pre-wiring is not required. Solar is optional. For mixed fuel multifamilies of large size, pre-wiring is required, and solar is required unless passive house. If it's passive house, solar is optional. Next slide, please. So this is a picture of new low-rise residential construction in Wellesley. I want to thank Janet again for this chart. And you can see that each bar reflects, like the total height of the bar reflects new low-rise residential buildings, number of new low-rise residential buildings in the given year. The orange part shows dwellings greater than 4,000 square feet, and the blue is under 4,000 square feet. And you can also see that between 2018 and 2020, about 55 to 59% of these buildings were greater than 4,000 square feet, and that's conditioned space. Next slide, please. We don't have a lot of time to get into incentives. The Climate Action Committee and other groups around town are working. We've been holding webinars about incentives throughout the year, and we'll continue to do so. But I just want to highlight that the kind of provisions that are set out in the opt-in code and in the stretch code, there are an increasing number of resources to help support the weatherization, electrification, energy efficiency, and solar. Also, I think something that we're going to be talking about as we get, work through our speakers tonight is that all electric homes are generally cheaper to build, and these high performance buildings are cheaper to operate. Next slide. So why adopt the opt-in code? We're going to learn more to support these claims as we work through other presentations tonight, but they're definitely necessary for meeting our greenhouse gas emissions goals. They help us to stop digging that fossil fuel hole. It's the easiest place to stop using fossil fuel is in our new construction, so much easier than retrofitting. So we need to take that low-hanging fruit, take advantage of that. And it helps us to avoid costly future retrofits, as we'll eventually need to be all electric. And especially when we're talking about things like passive house and all electric, encouraging those means that we're encouraging healthier, more comfortable indoor environments, and especially in the case of passive house, more resilient buildings. Next slide. And so now I'd like to turn it over to Ian. Really grateful to have Ian tonight. Thank you.
Thank you, Mary Beth, and thank you everyone for taking your time to learn about this topic. I'm Ian Finlayson with the Department of Energy Resources. And tonight I'm just going to give you a high-level overview of the specialized or opt-in specialized energy code. And then if there's questions, then we can get into more detail later as folks want. So next slide, please. So I'm going to start with the residential low-rise sector, then multifamily, and then we'll get to commercial after that. So next slide. So this is a sort of history of where we've come from in the era of the stretch code in Massachusetts. It's somewhat simplified because in the base code, you don't have to use the HERS rating index. And in the stretch code, you can use passive house instead of HERS ratings. But because HERS ratings are essentially an index or a yardstick for assessing the energy efficiency of homes, it's a relatively easy way to show how the energy code has developed over time. And what I want to draw your attention to really is the right-hand side of the slide here. So for the last couple of years, our new construction has averaged HERS ratings of 51 in both 2020 and 2021. That doesn't mean every house or every multifamily unit is hitting 51, but that's the average across 8 to 10,000 units every year that we build here in Massachusetts. That's quite different from what you might have in your own house if you live in an existing building or a historic building or so on. So I think it helps you understand where we are with the energy code. Now to go slightly more to the left, I've got a color scheme here with the stretch code in blue and then the specialized code in green. And what I want to show is that by 2024, the stretch code and the specialized code will have similar levels of energy efficiency in terms of HERS ratings. But if you adopt the specialized code soon, you'll essentially be adopting that improved energy efficiency slightly earlier. In this case, about 6 months earlier. Okay, next slide. So now to understand the difference between the stretch code, which Wellesley is currently on, and then the specialized code, if you choose to adopt it. I'm using that same color scheme where the specialized code is in green and the stretch code is in blue. And the point here is that the specialized code isn't actually affecting every building. And where it is adding additional requirements above and beyond the stretch code, we're trying to keep them fairly straightforward and simple, recognizing that this is going to be a conversation in 300 or so towns and cities. So there are not a lot of nuanced energy efficiency changes for you to understand, although there's plenty of detailed changes in the stretch code itself for folks that are interested. But the main difference between the stretch code and the specialized code is that the stretch code mandate, which dates back to 2008, is about energy efficiency. And the specialized code is really about decarbonization. And that comes from the legislation that established these two codes. So the 2021 Climate Act is what led to the opt-in specialized code being created. So for new low-rise residential, if you're building all electric, and we'll probably hear more about that later this evening, then you don't actually have to do anything additional in the specialized code. And that's because we think our electric grid will be, certainly by 2050, a clean grid. And so an all-electric home will be not adding any significant amount of greenhouse gases. Wellesley, as a muni MLP community, controls their destiny a little bit on how quickly you clean your grid. But the rest of the ISO New England grid that you're part of we project will be almost entirely or fully clean electricity by 2050. So the specialized code really adds provisions only to new homes that we class as mixed fuel homes. So that means they're using a fossil fuel or they can use clean biomass systems. Either way would trigger that mixed fuel definition. And if the new homes are under 4,000 square feet, then you meet the energy efficiency requirements of the stretch code. But then in addition, you would add solar PV and the wiring that Mary Beth mentioned earlier for future electrification. And that's to say, in the short term, if people want to have gas appliances or propane appliances or biomass as their heating system, then they can make that choice. But we want to make sure we're preparing those buildings when they're built for a clean energy future. So above 4,000 square feet, it's essentially the same story, but the solar requirements are greater. And this is relevant to communities like Wellesley, where there's a significant amount of new construction over 4,000 square feet. And so it says in the brackets there on the right that you go to net zero. And that's because that HERS index scale that we were talking about, you can get a lot of HERS points for a small amount of solar. And the intent of the HERS index is to show what it takes to get to net zero. So 0 on the HERS scale is a net zero home that's generating as much energy as is being used over the course of a calendar year. So we'll talk more about how much that generation is in a future slide. And then lastly, for residential new construction, if you elect to go with passive house, then we don't require you to put solar on the home, but we do require wiring for electrification if there are any fossil fuel or biomass uses. Okay, next slide. So just to explain that solar requirement, since that's one of the two main additions, again, it's a 4 kilowatt minimum for homes under 4,000 square feet. And then above 4,000 square feet, to get to net zero, it's going to really be home dependent, how much you need. But to give you a sense, we've seen 8 kilowatt systems in single family homes achieve net zero. But we've also seen homes that need up to 20 kilowatts to get to net zero. And so it's going to depend on the size of the home and the efficiency of the home, and something that the design team can then have some control over. For non-single family or two-family homes, we also have a sort of simple formula for how much solar would be required. So this would apply to other residential uses like senior living or small multifamily housing. Okay, next slide. When we move to multifamily, I have a fairly minimalist slide here because I know you're going to hear more about passive house from Hank. But essentially, the story of the specialized code is Passive House. If you look at the stretch code column in blue, you'll see that in the stretch code for multifamily, there are essentially 3 different options, whether you're all electric or mixed fuel, for complying with code. You can use a HERS rating, just like low-rise residential. You can use what's called the TEDI path, or you can certify to Passive House standards. So the big difference with the specialized code is that we streamline those requirements and say, new multifamily, if it's not low-rise and it's over 12,000 square feet, then it should comply with Passive House requirements. And then to be consistent with our earlier discussion about being ready for an all-electric future, if you have a mixed fuel building, let's say for hot water, using propane, then you have to pre-wire that building for future electrification of those uses. So I think that's all I need to say about that for now, and let's go to the next slide. Okay, so commercial buildings, next slide. So I'm going to use the same format here, and you'll see a lot of similarities between commercial buildings and the low-rise residential. Essentially, if you're all electric for any commercial building type, then there's no additional requirements in the specialized code. And unlike the residential sector, we already see that the majority of commercial buildings are all electric. So this isn't going to be a major impact for a lot of buildings. However, for buildings that do choose to be mixed fuel, then it's a similar pattern of we require solar and pre-wiring for future electrification. The scale of that wiring is slightly different for commercial buildings, and there's more of a custom option if needed. And the solar requirements are obviously commensurate with the size of the building. Again, Passive House is an option. Passive House can be used for any type of building. And if you do elect to do Passive House for a commercial building, then you don't have to do the solar requirements. And that's really a recognition of some of the grid side benefits and resiliency benefits that we see from Passive House. Okay, next slide. So we've had, since we put this language out in September, a lot of questions about solar on commercial buildings. And so on this slide, there are a couple of examples. I'm not going to go through them in detail unless there's a question about it later, but I just wanted to give you a sense of the size of system that would be associated with these buildings. So the first example, a 4-story high school, similar to the image that we showed on the commercial slide, that would require a 240 kilowatt solar system. And pretty much all of the new schools that we see being built in Massachusetts are building with solar in mind anyway, and typically putting on significantly larger systems than this minimum requirement. So we know that's a very feasible requirement to meet. And say for an office building, this is another indication of the likely system size. The calculation is essentially a simple formula based on the conditioned area of the 3 largest floors of the building. You'll also see in the code language that I put at the top of the slide that there are exceptions, and these are based around when there's shading on a site. And for that reason, there isn't a lot of potential for solar on the site. Again, we can get into more on that if needed. Okay, next slide. So obviously I'm around this evening, but if going forwards there are any questions, we're taking questions at stretchcode@mass.gov. And my colleague Paul Lamond and I will get back to you on those whenever you send a question. With that, I'll turn it back to Mary Beth.
Thank you, Ian. And I'm going to quickly pass it to Hank Keating, who is president of Passive House Massachusetts. Thank you, Hank.
Thank you, and thank you for having me. I'm an architect. I'm a retired affordable housing developer. I'm currently the president of Passive House Massachusetts, and I've spent most of my time advocating for passive house and greenhouse gas reduction programs in the state of Massachusetts. I've realized that I've been involved with passive house for well over 15 years, having designed my own passive house that I live in, and over 400 units of affordable housing to the passive house standard. So what is passive house? It's actually simply a formal set of building energy consumption standards that result in buildings that will use up to 90% less heating energy than typical code buildings today. So you just settle with that idea, 90%, it's extraordinary. I've built projects and documented that they meet that standard. That's not all energy used, but just looking at the heating side, which is the biggest piece of all this. So that's the potential for passive house. How do we make that happen? First, we do airtight building envelopes, and we combine them with the balanced heat recovery ventilation system. To give you a sense of scale on that, a passive house must meet essentially a 0.06 metric for air changes per hour. Code today is 3.0, and the house that you're probably living in today is probably between 10 and 20. So that tells you the extent to which passive house depends upon reducing air infiltration very dramatically. Once you do that, you need to introduce 24/7 balanced heat recovery ventilation. In addition to that, we come back and do continuous insulation without thermal bridging. We're doing heavier insulation than a normal building, but the key term here is continuous. We don't want it to be leaking in any points in the facade. And then we have to have high performance windows, either double or triple gained. And all of these features together actually minimize the space conditioning requirements for the heating system. I'm going to jump back up to optimization for solar gain. Optimization for solar gain in passive house is, in fact, an important feature in a single family house, like my house. I depend heavily upon solar gain. But in multifamily buildings, it's not the case at all. And this is a good thing, right? Because we can't have high rises that only have one facade facing south. They're going to face south, east, west, and north. So what we find out is that works perfectly well because smaller units concentrate the internal heat gains from buildings. And obviously, when you do a multifamily building, if you have an apartment, it typically has one exterior wall. That's 1 out of 6 surfaces that the unit has that's exposed to heat loss. So when you combine those things, the multifamily buildings are dominated by internal heat gains, and we do not need to worry about optimizing for solar gain. Next slide, please. So when we do this, what are the benefits? The first benefit actually is reduced greenhouse gas emissions and reduced heating and cooling costs. Then I would go to comfort, increased comfort. When we talk about the air changes per hour, the infiltration is draftiness. And we all know in New England that we've all been in many, many houses where it's drafty. And it's drafty and uncomfortable, and we have our favorite single glazed, double hung windows where we've got infiltration and we've got radiant cooling off the glass. All of this is what makes these buildings uncomfortable. All those problems are solved with Passive House. In doing that, because we're introducing 24/7 heat recovery ventilation, the indoor air quality in a Passive House, even though it's sealed up very tightly, is much better than in a house that doesn't have ventilation. One of the ways I like to look at that is to say, a lot of people, builders especially, will say, well, boy, if you seal it up like that, that's going to cause problems. Well, it would cause a problem if you didn't have ventilation systems, but the houses that we've built in the past depend upon infiltration through windows and infiltration through walls. So that's when you open up an existing house and look at the insulation in the wall and it's all covered in dark dirt. That's dark dirt that's been seeping through the walls through infiltration. That's how we used to ventilate old houses. We've moved on and started intentionally ventilating them. So we get much better indoor air quality. We get resilience, and that's resilience in terms of durability and shelter in place. Because we have a quality control procedure for building a Passive House, we make sure that we are solving building science problems in the construction of those walls. And then we've created a building that's much more durable. It's not subject to leaks and water and air infiltration into the building. And then it offers the real potential for shelter in place. When the power goes out, you can a Passive House building can coast easily for 3, 4, 5, 6, 10 days, depending upon the weather. You don't have to run to the Hotel 6 immediately and your pipes aren't going to freeze. Future proofing, we all know what's coming. Building Passive House today means you're building something that you're not going to have to redo. And Passive House is financially feasible. Let's look at the next slide quickly. This is just to make the point, because we have so many examples of Passive House housing. Passive House is for all buildings, as Ian was referring to. We've got schools, single-family homes, and the largest Passive House office building in the world right now is going up in Winthrop Square in Boston. So it covers all the building types. Next slide, please. So this was obviously the question that we got 5 years ago when we really started introducing Passive House and hoping to get it as a requirement in codes, and we finally are getting there. The questions were, how much more does it cost? And what we did is we worked with Mass CEC to come up with the Passive House Design Challenge, which offered affordable housing developers money to enter this and convert a design they had to Passive House, and then track the cost increases very carefully. And this is the result. So the goal was to keep it under 3%. And you can see with the exception of one here, two, they were essentially under 3%. I draw your attention to the one that's 4.3%. Look at the complexity of the roof lines and the dormers. That's one of the reasons that it costs more. Passive House is best suited to more simplified buildings. Next slide, please. So the incremental cost findings from the Passive House Challenge were that the average was 2%. Now, I would stress that this is designs done in 2018 with projects being completed over the last 3 years. We've come a long way, and we will continue to come a long way in pricing. So we say that with the right design team, going down to best practices, if you have the experience and the training for your design and construction team, and you simplify the massing of the buildings, or let's say don't get too complicated, you can keep the cost to a 0 increase. Or maybe it's 2%, but it's not hard to keep the additional costs down. And you want to understand that your cost savings are reducing heating and cooling costs going forward. So you're going to make it up over time. Next slide, please. This just is a quick slide to show you the nature of those buildings in that challenge. Next slide. And I'll close with this. So we have the Mass Save Passive House incentive program, and I know that doesn't apply in Wellesley because you're a municipal light plant, but this shows you the extent to which over the last 4 years, we've gone from literally 98 units of Passive House in the state of Massachusetts, multifamily, to over 10,000 registered for the program. This is, as I would like to point out, 40% of these are low-income projects and the rest are market rate. So the Passive House is being picked up by contractors and developers across the state. We're learning how to do it. It's not that expensive. And I'll close with that and answer questions later. Thank you.
Thank you so much, Hank. And now we're going to turn to Mark Doty, who is principal at ThoughtForms. Thank you, Mark.
Thank you, Mary Beth. And I'll just follow on with Hank's points. What I thought I would do is just talk briefly about some common questions that we've come across through the years of building high performance homes. As Mary Beth mentioned, I'm the principal at ThoughtForms. I've actually taken this on as a cause to some extent, where I've provided testimony at the State House and all electric buildings, and spoken at town meetings in Arlington, Acton, and Lexington. And I think what we have tried to do is share our experience, because what I find is often an obstacle to these kinds of programs is the misperceptions that exist in both with builders and also with clients, homeowners. So Hank just briefly talked about the upfront cost premium that people are experiencing. When I've spoken with groups before and asked people to write down on a piece of paper what they think the cost premium is for building to net zero standard, they commonly are guessing 10, 20, 30% cost premiums. And the reality is, like Hank just showed with the Mass CEC example, we're seeing between 1.5% and 2.5%. So one of my partners did his PhD at MIT, or I'm sorry, his master's thesis at MIT on the cost premium associated with LEED construction, which includes more than just the home and more than home energy. And what he found in his study was it was about a 4% premium, which again, that includes more than what we're talking about tonight. We've looked at a couple of projects that we've done at ThoughtForms, and we have found between 1.5% and 2.5% premium. Hank mentioned some of the cost drivers of the premium. I think the one other one that we have seen is the cost of bringing a gas line in from the street, the site work associated with that, and then the plumbing work associated with it. And another cost driver we've seen, and this again for builders who are thinking about this, are the window and door jamb extensions on the exterior. So for our experience, the first time we did a home with rigid exterior insulation, the continuous insulation that Hank was referring to, we found there's a learning curve. So I do want to say, if you're a builder and you're looking into moving into more and more high performance construction, it is worth speaking with people up front and gathering as much experience as you can from the market. Because like I said, when we first did this 17, 18 years ago, it wasn't as common a practice. And so we did experience a bit of a learning curve then. I think switching to the next question, how much will I save on my monthly bills? And that's another common question we get from clients. Here, we're seeing clients getting somewhere around $7,000 annual savings, so somewhere in the $600 a month savings on utilities. A caveat here is We have one client who their home actually is net positive. They generate more energy than they use, enough to generate or to drive an electric vehicle about 30,000 miles a year on the excess energy they're producing. Now, the way that they operate their home, they're very thoughtful about energy use. And the house is designed to have fewer loads than we've seen in some other homes. We have another home where it was designed to be a net zero standard. The client also, just through their habits of living in the house, they tend to be an always on kind of family. So they keep lots of things running in the house. They have an extensive AV and entertainment system and lots of Wi-Fi and technology. That's running and using a bit more energy. And then they also have a small wine room that has a separate unit for cooling that wine room. And that actually, they're spending a few $100s a month, when if you look at their HERS certificate, it says they should be at zero. So there is a bit of occupants' habits that are going to impact the monthly bills and how the house performs from a financial perspective. I would say that our experience is that commissioning the house and actually tracking how energy is being used is really important. So again, the home where the people found that they were paying bills when they expected to have no bill, we have a monitoring system installed in the home, so we could just bring up their electric usage. And a couple of interesting things we found was that, one, the eco mode on the air source heat pump that they're using for their hot water is actually less efficient than the heat pump mode. So if you're a plumber, if you're a builder and you're going into the house and you're installing this air source heat pump, you would think that eco mode would be your most efficient mode, but actually setting that to heat pump mode saved them quite a bit of money on their monthly bill. And the other piece that was missed during the commissioning was the house has a recirculation pump so that hot water is available throughout the house at all times. That recirculation pump has artificial intelligence built into it. So if you run it in AI mode for about 5 days, it adapts to your usage of hot water, and then it only runs when you will be using the hot water. If you don't actually run it through that mode, it runs 24/7. So again, these homes are designed to operate in a certain way. We've seen them work really well. The trick is that you do need to pay attention to how they get set up and make sure that they're running the way they were designed. And then also education of the homeowners. I think moving into the risks and the compromises, that really goes more into the perceptions again. In terms of risks, I think that I have heard many clients say that, oh, this is unproven technology. As Hank said, it's been around for a while, and we have used a lot of this technology actually in my own home as sort of a testing ground and found it to be very, very reliable. The heat pump, I believe, was patented in the 1940s, and the gas boiler, the boiler was, I think, patented in the 1920s. So neither one can be seen as brand new technology. I think the other risks, Hank touched on the concern about the house being too tight. I think that's something that we've been able to talk clients through and other building colleagues so that they understand that's not the case. And then in terms of compromises, I think probably the biggest emotional compromise we see people faced with is the loss of a gas stove, a gas cooktop. And again, I think if we can get people to try induction cooktops, we've found them to be very happy with them. They're safer. There's no combustion gases inside the house. There's no waste heat making the kitchen uncomfortable when you have company over. And I actually have used a story of a friend of mine who was the head chef at a French restaurant in Seattle. And when they tried to recruit him to take over the job, one of the conditions he made was that they convert their kitchen to induction stoves, with just a couple of burners for dishes that they needed flame to prepare. But he, as a professional cook, liked the induction because, again, more comfortable to work around, safer. They weren't burning their jackets or their hands, and they could prepare meals very, very easily and happily. I think I'll stop there and leave more time for the Q&A. But I think what I'm hoping is if people have questions about does this work and how does it work with people in our community, we've seen it work very well. And as I said, we've been doing this for a long time. So with that, I'll turn it over.
Thank you so much, Mark. And now I want to see if are there any hands raised right now? Because Jen, I'd like you to keep the slides up. But can we, I don't know if Martha sees any, if we don't have any questions. No questions. Okay. I would like to, Jenna, maybe you can, Tom Catalano, maybe we can have maybe 2 minutes or so, 2 or 3 minutes on your comments. I know that in talking to builders around town, talking to luxury builders, for example, I did run into concerns that they were having about the compatibility of the kind of building that the opt-in code encourages versus what their vision of a luxury home is, even down to the aesthetics of a heat pump mini split on the wall. And so I think Tom has some pictures for us and some experience that he can share with regard to this luxury home arena. Thank you, Tom.
Thank you. Well, we've been trying to build high performance homes for a little bit over 15 years now. And I just had a few examples to show you that there are ways to achieve a sort of a traditional aesthetic while still using many of the components of a high performance home. This particular house has we had a very high level of attention paid to the indoor environmental quality. It's one of the first projects we did with an earth coupled heat pump system. So it's been in operation for 15 years. This particular one had a standing column type of earth coupled heat pump. And it had very traditional materials, but a lot of attention paid to the durability of the building envelope. Some parts of this had continuous insulation, but not all of it. Some of the other slides we can show you, I think. These are just some of the photos of the inside of this. I'm sorry, I don't know. I'm not sure what Mary Beth has for the slides, but this house has, of course, a couple of energy recovery ventilators. It's a very, very tight house. Mark's company built this house and maintains it. And I think you can see that in this example, there aren't many aesthetic compromises that one would have to make in constructing a high performance building. This is an example of another project we did in Dover, Massachusetts, which again was a high performance building. It had again earth coupled heat pumps with 2 standing column wells. And one of the things that we did in this project is we had a high performance building wrap with continuous insulation. So this shows after the conventional framing was up, we did the building wrap, and then we did a 2-inch rigid insulation board to give us the continuous insulation to get rid of the thermal bridging that Hank was talking about. Greatly improves the performance of the building. Also applied this in a rain screen type of system to increase the longevity of the siding itself. And these are just some of the things before the building wrap and before the exterior continuous insulation goes in. You can see that special care has to be taken to extend all of the jambs at the rough openings to deal with the continuous insulation, and have to pay very careful attention to the way each of the window units are flashed. And this application was a continuous layer of uncured rubber membrane self-adhered on the sheathing before the rain screen and continuous insulation went on. And that's just another shot of it after the board goes on. But we've been doing both earth coupled and air source heat pumps for a while. I think Wellesley is blessed. I know you have a municipal light plan, but you also have a good part of the town served by 3-phase power, which, especially on projects that are over 4,000 square feet, makes it very easy to have a super efficient air source VRF system. And a VRF system is what the essence of a mini split system is. But when we do the VRF system, rather than having the wall mounted units where you see the machine exposed in the space, it's the same machine, but it's built into a plenum and it's ducted. So one of the things you get out of the VRF system, which is what the mini split is the ability to have very small zones, multiple zones, and really improve your building performance by able to zone for suitable occupancy. One of the things that we gives the client the ability to really control the spaces based on how they're used. I know one of the questions that was raised to Mary Beth in the lead up to this was that the air source heat pumps or air systems in general tend to deteriorate the indoor environmental quality and make the space dry. That's quite easy to overcome in combination with the energy recovery ventilation system. Most of our systems have the ability to introduce additional moisture, injecting steam into one or more of the zones. So you can actually have the ideal indoor environmental quality. You can maintain 35% relative humidity year round quite easily. And that's something that all homeowners in the market for these projects that are over 4,000 feet in Wellesley would expect to see something like that.
Yeah, and Tom, if I could just add to your point about the humidification in homes, we even find when they're built tight, you're not leaking out a lot of the warm, moist air in the winter, which tends to strip the humidity from a home. So even the humidification requirements tend to be reduced if you have a very tight, well-insulated home and an ERV in function.
Very helpful.
Thank you.
Thank you. Thank you so much. Thanks, Tom. Janet, maybe you could stop sharing. I think that that's the end of our slide deck, and we can see if there are really encouraged questions, if anyone has them. Since we have all these experts here tonight, it's a great opportunity. But if there aren't any, oh yeah, we do. Great, Jake.
Yeah, hi, good evening. Thanks, everybody. Jake Lilly. I run the architecture firm here in Wellesley. Just a quick question for Ian, and thanks to all the panelists. So you guys showed two slides today. One was new low-rise construction in Wellesley, and you followed that up with another slide, specialized versus stretch code. So the first slide you guys showed was all new construction, which is great. Obviously, you're going to make a large impact with new homes. I imagine Michael Grant probably sees a lot more permits coming across his desk for alterations and modifications to existing houses than he does new homes. And which is why I want to just look on the specialized versus stretch code slide you showed. So at the bottom of that, there are two different sections here. I'm just go into it myself here. One was historic or existing homes. The other ones were home alterations and additions. Under the existing homes, energy code not applicable. Under home alterations, same as a stretch code. So I was having a recent conversation with one of our stretch code consultants, or excuse our HERS raters, I should say, and we were just talking about their job and their ability to generate accurate HERS ratings. And, you know, in a nutshell, new construction, additions, things that are easily identifiable, quantitative, those are, you know, aspects to the building world, which they can perform some strong analytics for. But there are many houses, and I'm not sure the DOER has fully vetted this out, and that's really where my question lies, where you will have a house, let's just say it's 6,000 square feet, and a homeowner wants to do an addition onto it and also wants to modify, say, 1,000 feet of that existing house. And so you wind up with a house with 5,000 square feet that's existing, 1,000 square feet that's modified, and some kind of addition. And the addition is highly quantifiable from a HERS rating standpoint, but there's a very big gray area between how the rest of the house is, how the HERS rating is applied to it. And so the question to Ian is, are there technical guidelines coming down the pipe for municipalities that help address how HERS raters are supposed to deal with, let's just call it gray area evaluations? Because I'm not quite sure some of the building inspectors I've talked to in certain towns know how to answer this question. One of them went as far as to say, well, I just don't know how I give somebody a building permit if they're supposed to pass a HERS rating and the HERS rater cannot perform their task due to the variations in the house type. So sorry for the long question. Hopefully, hopefully there's some benefit from your answer to all of us. Thank you.
Yeah, okay, I'm happy to take that one. Thank you for the question, Jake, and for the sort of background to introduce it. So, and the first thing I would say is this is a question about the stretch code that's been updated and not about whether you choose the specialized code or not. So I think Jake understands that, but I just want everyone to understand that. And really what we are seeing in the update to the stretch code, it's the first time that we have anything that triggers an addition or a substantial alteration of an existing house requiring you to look at the whole building to upgrade that whole building. And that's what the HERS rating does. The HERS rating is an assessment of a dwelling unit rather than an assessment of, say, just the addition. Now, if the addition is itself like an accessory dwelling unit, like an in-law apartment or something, or has the features of a dwelling unit, so if it has its own kitchen, bathroom, and sleeping rooms, then you can do a HERS rating just on that portion. And I think, again, Jake understands that well. The tricky situation is where you are substantially renovating an existing home, but not all of the home, and you're not really adding another unit. And, you know, this was a big policy discussion internally, but I think the policy came down that these are the kinds of projects where we do want people to have to think about the impact of the whole house when they're putting that level of investment into a home. Now, technically, in terms of a HERS rater being able to provide a HERS rating, I sit on the Standards Advisory Committee for ResNet that develops the HERS rating. So I'd be happy to go down that rabbit hole with you sometime. I'm not sure if that's not really a short conversation, but Jake is right that there's much more precision in a HERS rating for new construction, where you know all the details of the wall and the level of insulation and so on, and it's harder to get that precise for a combination of an existing building and a new addition. But it is doable, and HERS raters do it every day. And I'm sure there are no shortage of HERS raters who are willing to do that work. I think what we're hearing from HERS raters, and again, this is in stretch code, is that they are uncomfortable with going from being a supporting service to the building code to now becoming really a critical player in getting some of these renovation projects to be code compliant. And that sort of reflects the nature of our climate challenge, I think, that we do have to renovate our existing building stock over time. And we do have to start that process now if we have any hope of getting to our 2050 goals. And so it is thrusting energy more into the spotlight. So Jake, I know there's more detail that I'm sure you and I could go into, but maybe we should pick that up offline.
Yeah, I'd love to do that, because I did query some of our clients, and you know, a lot of these people who have large homes basically said, well, you're not asking us to renovate our entire home to be permittable if we're just redoing a kitchen and an addition. And the HERS folks said, yes, you shouldn't be counterweighted by the inefficiency of the old houses, which, you know, per your existing homes is not applicable. So yeah, love to take it offline, Ian, and thank you for your time again.
Yeah, and just for everyone else listening along, the threshold is it more than 50% of the space of the existing home? So if you are just looking to renovate your kitchen, or say a portion of your ground floor or something, that isn't going to trigger these requirements. But if you do renovate more than 50% of the space, or the addition plus the existing space triggers more than 50%, that's when this HERS rating requirement kicks in.
And if I
Ian,
could, sorry.
could I
Oh,
just
sorry.
add,
Oh,
sorry.
go ahead,
No,
Mark.
go ahead, Laura. I
I was just going to say, and if I could, I just, Jake, if you really want to continue this conversation with other engineers and architects who are going through the same thing, we have the BSA we have a series of the discussions about the stretch code going on, and the one for March, they'll be on March 31st, is about existing buildings, both residential and commercial, and we're all working through the same thing. So we've been, trying to use our shared experiences of going through this and trying to figure out how best to keep it moving through.
Great. Yeah, happy to join in.
And one thing I'd just like to add from the experience side as well is that when we've been doing renovations recently and going back a number of years, even if we're adding only to a part of the house or doing a renovation of part of the house, we've gone in and done blower door testing to identify sources of air leakage. And that is one thing that you can measure, and you can measure the improvement that you're making on a home. So even if you're not renovating the entire home, you can do some pretty effective air sealing and improve the performance dramatically. I mean, I believe in New England, about a third of the energy used in a home is used because of the air leakage. So if you can just work that number down, and I think somebody had mentioned, I think the average home, or the home people are living in, about 10 ACH 50. And we're getting them down below 1 ACH 50 during renovations without redoing the entire home. That's just another, that's an actual metric you might be able to work with.
Thank you. Thank you all. Any other questions from the floor? I don't see any. I'm going to ask a question that I ran into in talking to builders, and that is the question about heat pump water heaters and the viability of those in homes and in larger buildings, and whether they were sort of ready for prime time if you're trying to go all electric in a building. So I wondered if anyone on our panel, I know I've talked to Hank about this question, so maybe Hank, you want to take this, but anyone else on the panel who's wants to talk about heating water?
Yeah, I'd be happy to start the conversation. My view is that heat pump hot water heaters are perfectly suited for smaller residential buildings. Single family homes, certainly. No, I don't see anything standing in the way of the capital or operating costs for single family homes. The debate that's come about in the multifamily building community is that because they are slow to make the hot water, in effect, like a heat pump is slow to make heat, they require a lot of additional tankage to have the volume they need to satisfy demand at certain hours. So it literally can be a situation where they have a heat pump hot water heater on the roof. It costs more to install it, not so much more, but it's more. Then they have to have more tankage. Sometimes they have to increase the structure to hold that tankage, and it costs more to operate. So it's definitely been an issue for multifamily housing, but I think it's an issue that's going away. People are starting to just simply say, look, we're committed to go all electric. There are some premiums here, and we're going to do it. But it's going to cost you some more, both from capital point of view and operating point of view, on multifamily for sure.
Hank, do you think that the lower electricity rates in Wellesley might soften that blow for municipal light towns like Wellesley?
Absolutely. Absolutely. We see the differential between, I don't know Wellesley's numbers exactly, but the differential between MLPs and other jurisdictions can be threefold. So you could be paying a third of the electric rate, and that has a huge impact on what it would cost. There, in that situation, the heat pump hot water heater wouldn't cost more to operate, but it may still have an increased installation cost for large installations.
Thank
But
you.
the light commercial that we have in town, I mean, we don't have that much multifamily, large multifamily, but in Wellesley we have a decent amount of light commercial, and often these all have boiler fed hot water tanks or hot water tanks with fossil fuels. You know, on demand is perfectly acceptable for these small needs. They're work really well. Most other countries use them regularly and are very comfortable with them. It's you know, that's an easy switch for the kind of commercial side of things that doesn't have that high demand that, you know, Hank is talking about.
Great point, Laura. Thank you very much. Ian?
Yeah, I was just going to jump in and say that if I think the situation in Wellesley where this would come up would be commercial multifamily or commercial retail or some use like that. And the cheapest option if you have access to gas is probably to use gas, hot water, and put solar on the roof. And the specialized code would require then pre-wiring that for future conversion. So if the only consideration, and legitimately for real estate developers that can be the case, is economics, then the specialized code allows you to do that. The cheapest upfront construction cost option is to just use electric resistance hot water. And there's a lot of development in the national model code, bearing in mind that at least half the country doesn't have access to gas, around just making sure that hot water distribution is efficient. And then electric resistance hot water isn't necessarily a terrible solution because you can cut down on the distribution needs significantly. And so if you look at even affordable housing in, say, New York City, you see almost all of it is electric resistance now, not gas. And then if you don't have access to gas, then if you're comparing against propane, then electric heat pumps are going to win every time. Nobody's really considered using heating oil for water heating for about a decade. So I think maybe this issue gets overemphasized as a challenge. I don't really see it being a challenge discussed in the affordable housing community outside of a few individuals. And it's not something that's impacting other markets where they don't have gas connections.
Good point. Yes, thank you, Ian. I guess one last question that I have is, in talking to builders again across town, just something that came up was the role of builders, home builders in educating clients. And I'm curious, Laura and Tom and Mark, to what extent you find yourselves in the role of sort of educating your clients about sustainable design and helping them to understand things like cost savings for operating, for the operation of the buildings and things.
I can start. Go ahead, Mark.
No, go ahead, Laura.
Of course, I think the role of any design professionals is, as with anything, where our profession is probably different than the people that we're building the house or the building for. That's not their bailiwick. We are, that's part of our role, and as is true for anything we're doing in life. When you're trying to, buy a car, if you're not a car professional, you're looking for someone to help you through that process. And change is hard, but a majority of this change is already going to be in place with the stretch code. We're already going to be at high performance buildings. These are, it is a move to that, and we've been moving that way for years. I think there's a real thought that this is a big jump, but we've been doing, the fact that we're having these discussions about heat pumps, and we've been having them in town for numbers of years, these are not new. It's not brand new for this time. We're all pretty comfortable with them. Everyone knows when you say that that's what's on a wall, that mini split, people know what that is. Then that means that we're all pretty familiar with it. So I think we have to give everyone the credit that they know a little more than they think they do as well, as do the builders. And I understand that, it's hard to do things different than maybe they were, but that's why we're all in this together and working through it. And I think you've heard Mark and Tom and everyone say they've been doing this for numbers of years with that. But I can definitely have had these conversations with builders, but you have that with everything. So I don't think that it's there's that's what these talks are for. There's lots of resources out there, and I'm sure if anyone reached out to an architect or to Thought Forums or any of Auburndale Builders or any of these, they'll be happy to talk with you further. There's also a lot of classes in education. I know of many people offering these classes for builders and design professionals.
Yeah, I think I would add that I think it's been great to see over the last few years. I think there's really been some movement in the right direction here. 20 years ago, we were putting in ground source heat pumps because they were perceived as preferable to having condenser units in the yard or noisy equipment detracting from the landscape. So we were doing this work for different reasons. People weren't as focused on the environmental benefits of the work, but they've been in high-end custom homes for years. And I think, I go back 5 years ago and some of our competitors were actually using our position on sustainable construction and taking a more forward-leaning approach on that as a detractor. And they would say, oh, Thought Forms is too green. You don't want them to waste your money. And they were promoting this idea that there were negative connotations to sustainable construction or green building. And I think that noise in the system, as some of our competitors, I think they've evolved and they're taking a different approach as well. You're seeing articles in the New York Times. I think there's just more out there and people are more receptive to the conversation. And now it's really time to just get the data in people's hands so that they can match their perceptions and beliefs and align them with actual data.
That's great. Thank you, Mark and Laura, for that answer. I noticed, Jim, you want to ask your question?
Yes, hi, Jim Kalopoulos, KBC Builders. I have two questions and one comment. I think clients are aware today of what's going on, and not only on an energy cost basis, but on an environmental. So I think they're all open to these type of ideas. That's what we're finding. In Wellesley in particular, it's a very, there's a lot of trees in Wellesley. Are they going to relax their codes on cutting trees around the house, listening to Hank with solar gain and solar panels? That's one question. It's tough to cut trees in Wellesley around the house right now, but I think it's necessary if you're going to do that. And the other thing is, is MLP looking at the future expansion of the grid in Wellesley if everything is going electric? As you are considering what's going on building wise, they need to be considering that as well.
Yes, thank you, Jim. I'll take the MLP grid capacity question, but welcome anyone else from Climate Action if they want to jump in on that. But I mean, the short answer is that the MLP is extremely aware and focused on beneficial electrification and what that means as far as their capacity to provide, enough electricity for the town. And I think, we have every confidence that they are doing what they need to do to make sure that we are set up for that. So that's a very general. I'd prefer that an ML they're very they work on this every day. In terms of understanding what their needs are and how they're going to meet them with regard to infrastructure and the contracts that they're pursuing and things like that. But I don't know if anyone from Climate Action wants to add to that answer on the MLP work. And your your question about the trees is a really good one. I've been getting that a lot. So my understanding is that the code does not require that you cut trees, but to allow for solar. Maybe Ian can answer that.
Yeah, no, thank you for the chance to talk about this. I mean, so part of our climate plan is actually to maintain and increase tree cover in the state. And so we don't want our building code to be at cross purposes with that. And personally, I think that wooded lots can be very attractive lots. So there's no requirement to cut any canopy, and certainly if there are mature trees on site, they can be adding value to the site. So the way the code handles that is that when you're designing the house, you look at the shading of the planned roof of the home, and that sets the solar area for that home. And if the solar area is less than 300 square feet, then you're essentially exempt from the solar requirement, even if you're a mixed fuel building. And we'd rather keep the mature tree canopy than have that size system. And just the economics of solar systems, it makes sense to not put like a 2 kilowatt system on a large house. So that's why we have that 4 kilowatt minimum, and then above 4,000 square feet, larger than that. So so if you have to choose between trees and solar, I think we would pick trees. So I hope that addresses that for you.
And also, I think Hank would probably weigh in on this, that while we want the solar gain on some sides, we definitely, and at sometimes, the east and west, usually we still are happy to have some trees. And so I think it's going to be a hard sell to take them down, even with the passive house design.
Great. We have a question in the chat by Roger Luckman. And he is asking about supply chains and materials and equipment needed to address both the updated stretch code and the specialized code, and wondering if there's any concerns about that, the availability of equipment and materials for meeting the code. So I'll put that out to our panelists.
I can say that I know there are some electrical components that right now are quite long lead items. But if you look a little deeper, you'll see that in a couple instances, the most acute instances, there's only one manufacturer currently producing the product, and their competitors have announced in recent months that they're going to be going back into production of these parts. So I think that there's also a shift in the industrial base as this codes start to move across the country, and you start to see the demand shift towards electrification and the needed components to produce. So I think yes, there are some shortages we're seeing in the supply chain, but I think we're also seeing the supply chain react pretty quickly.
And I think we're still a little, especially in the electrical world, commercial and I'm sure residential, but we're still a little behind from some supply chain issues during the pandemic, and we're still struggling with a few of those, mainly again around large transformers and generators and that sort of thing. I think that as Mark just said, there are people looking to capitalize on that and move it forward, because it's we are a capitalist location, and people find the vacuum. So we're definitely seeing changes there. I just it just takes a little bit of time. I am not aware of any changes, any shortages due to the stretch code or the implementation of the stretch code or the specialized. I've not seen that. We're back. We had some time during the pandemic where insulation was hard to get, or roofing materials, that sort of thing. But again, we're pretty much back on that, in all fronts that I've seen.
Yeah, I would just add that there are supply chain constraints from time to time, but none of them are impacting whether you should pick the stretch code or the specialized code. So people often look for something that would be a reason for delay, but there isn't really a relevant argument for that specific choice right now. And so I think folks should be aware of that. Hopefully for everybody's economic interests, these supply chain problems get solved, but yeah, we see more of an issue locally with supply of land, builders having places that they can build, and with supply of skilled labor, just because it's a tight job market. And we are working through the Mass Clean Energy Center and the Mass Save program to really ramp up workforce development training to try and make sure that we have more skilled tradespeople who can work for some of these excellent design companies. And I think nationally there's recognition that there's a shortage of electricians. That's somewhat related to the way that business has evolved over time and the apprenticeship requirements and so on. So again, electricians are needed whether you're building to the base code or the stretch code or the specialized code. And the other thing that we learned in researching this, sort of looking at electrification of buildings, is that where we see significant increases in load is not in space heating, particularly as you get to passive house levels of buildings, more efficient buildings. The increase in load that we see is coming from electric vehicle charging more than the buildings. And so what's critical there is having the control technology to plan and control when vehicles are charging, whether they're school buses or personal vehicles or something else. And that can actually be a net asset to the grid. May not require a lot of big grid investment because you can control peak charging rates and help reduce demand instead of sort of having just a net increase in demand. So again, another rabbit hole we could spend a lot of time on. It's a fascinating topic, but it's not nearly as scary as we thought it might be when we started looking into it.
Right, thanks, Ian. And the addressing or encouraging off-peak electricity use is very much in the toolbox of our municipal light plan. And in addition to looking at infrastructure and things like that, they're very much engaged in demand management and looking at a lot of different strategies for doing that. So we are approaching 8:30 and Fred.
Yeah, just I know we're approaching 8:30 and this is being over. And I just wanted to throw something out. I'm the leader of the building working group, and we have a monthly, not monthly, but quarterly meeting with the commercial building owners and managers. And I'd just like to throw this out to the group if you'd like to think about a quarterly get together of builders in town. I think the Climate Action Committee would like to help us, build sustainable and energy efficient buildings. So just you have Mary Beth's email. If you'd like to continue something like that, maybe we can put something together, but really appreciate everybody's interest in this and help. So thank you.
Thanks, Fred. That's a great invitation. And so I want to just, again, thank our panelists. I want to thank all of our panelists for being here. Really appreciate the expertise and generous answering of questions. And I want to thank Fred and Janet and Martha for being here and supporting this webinar. And if we are doing a second night on Wednesday, if you feel like coming and being part of the general public and listening. So, again, we'll be in touch with recordings and slides. So, and please be in touch if you're interested in meeting with us on a more regular basis. Thank you.